my beard.
I don't need to. So first, I'm going to start off by just saying I think it's fantastic. So when I first started being a bronchoscopist, there was one piece of technology that was added to the periphery beyond the radial probe, and that was the original yellow box from SuperDimension. And now I'm looking around, and we've got obviously multiple different people trying to work several different ways, and we're on obviously multiple generations later of SuperDimension, several robots, several different imaging, things that help us with pathology, etc. So it's incredible. We really, this is a microcosm of the beauty of our field and how much R&D is going on, because it still represents the profound unmet need of what happens when I have a nodule present inside the periphery, right? And CT to body divergence continues to be the Achilles heel for every single one of us. And as you just kind of heard, here's my conflict of interest as of, today. And if you don't see your company's name on there, what's wrong with you? Give me a call. There's no way you need a microphone. All right, so I'm very spoiled. Here's what we currently own at the University of Chicago. So we've got a Monarch, through ours, LungVision with body assistant, we have an Illumicite system, Archimedes, Rebus, we have the Celtivity system for acquired ASP Health's automated ROSE device. Though it's not yet FDA approved, there's a good, decent chance we'll have the NOAA Galaxy as well, I've been told. All right, so our first attempt to overcome CT to body divergence was an attempt to merge technology. So here I am in my room of toys, combining the Monarch and Archimedes. Because the idea between Archimedes was to actually tunnel between vasculature and airways to get to lesions that were eccentric, which has always still been a challenge for us. And with CT to body divergence, it's an internal problem that you hope that whatever targeting system you're using, it represents the lesion. But before I go poking through airways and through, especially if I'm in the kind of middle central thirds of the lung, potentially large vasculature, I'd sure like to know. So here we are combining them. And so you can see here the quick survey of the room. We're driving the scope over here. We've got the fused fluoro over there, and then a couple of other toys, and we've got cytology working in the background. But the idea core behind this is that you can take Archimedes and merge it in together with the Monarch and help plan where your exit point should be. Now the problem, of course, when you go combining technologies that aren't inherently built to play together is you are looking at multiple screens. You are one person standing in a room full of equipment, but it is actually really kind of cool. And what I will throw out there, especially because they're not present in the room here, one of the things they do with this virtual overlay and the ability to see vasculature in real time, obviously based off of CT, no company has yet replicated this interesting technology to help guide the endoscopist while we're working to understand where I should not put a needle, right? So this is a really neat idea of the fused thing. And when we were presenting this case, here was our problem. We found our lesion, we talked about Rebus, we see a nice eccentric view, but you also see a very large piece of vasculature that I had really little interest in going through. And so what we ended up doing, because of that fused fluoro, we were able to dig a hole. This is one of the powers that comes from robotics, is to be able to see and have that control. You can see the lung there, and we were able to then nail this thing, and it was unfortunately an adenocarcinoma. And so this was interesting, but quite cumbersome, I will say. We were glad to do it, but the cases were a little long, but it did represent, at least from my perspective, one of our first adventures to try to overcome CT to body divergence, because, and somebody's going to talk later, I presume it's going to be Mike or Krish about cone beam, and as fantastic as cone beam is, my hospital's problem is I have to give away a kidney to get access to it, and I only got two, now one, and so, this is our problem. So now what I want to talk about, is what I've been tasked to talk about, is LungVision, and the utilization of a tomosynthesis tool to overcome the fact that CT to body divergence is a thing. And so here's an example, and this is obviously, I'm a Monarch user, but the thing that's really nice about this tomosynthesis tool is agnostic to what platform you're using. So that is clearly a Monarch bronchoscope, but that can obviously be an ion scope, it doesn't matter, that can be your thin scope, no one cares. It could be their catheter if they want to buy their catheter. But what you get in real time besides this overlay is this yellow ball actually represents the lesion, because you did a tomosynthesis spin, and it's not a question of a virtual representation of it, you saw it on tomo. That yellow ball is definitively the lesion. So when you see your tools go in it, you know you're there. And that's a huge benefit to the bronchoscopist, because number one, the more I know I'm where I belong, the more aggressive I am about my sampling. I don't want to cause a pneumo and no diagnosis. But I will gladly cause a pneumo if it's going to give you a diagnosis. So So I will biopsy the crap out of something when I know it's there, right? And so what that does, and the way this tool works, using any C-arm, I'm able to quite literally, this was an 8mm lesion, we zoom in and we're able to mark it, and what it gives you in real time is this fluoroscopic overlay. You've navigated out, you can see a yellow ball. That yellow ball is real. There's me looking with a Rebus probe, more because like old school, like to be able to see it. But here we are putting a needle in. Now, what this video doesn't show you is then I swing it to LAO40 and RAO40, and I'm still dead center in the middle of the yellow ball. If I can see in 3 planes that my needle's inside the yellow ball, where am I? I'm inside the lesion, because that yellow ball is what I just saw under fluoroscopy, right? So it's a nice technology that partners easily with what you and I are trying to do. So here's a great example, because here's this kind of funny, wispy-looking lesion. And I'm going to show you this. And we couldn't get the scope out very far based on complex airway issues. But there we are, pushing our needle pretty out very far. We're going to keep zooming in, a little wispy thing. There it is, you can see it. We all agree there's a little density right there. Kind of matches up with that. So I'm going to mark that. Okay. So am I in the lesion or not? And I know Chris and I have had, many of the people up here have had this conversation. Are you where you think you are? And when you're a tumor board and you don't prove cancer, they get the immediate, well, way to go, Hogarth, you missed again. So everyone look at this. Look at me, I am in the lesion. And that's with a C-arm, by the way. Good old-fashioned, regular GE C-arm. Dead center. So when my thoracic surgeon's like, you missed, I show them this. And then say, no, I didn't. And then I point out the time they did a VATS and they missed. So here's Dr. Hedstrom. Great job. There you go. Our former IP fellow who decided to slum it and now works with HUBDA. And so this was our first 45 patients combining the Monarch with LungVision. And so average lesion was, this was Grady. Grady presented this morning. 16mm lesion on average, as you see, ranging all over the place. And did we get to the lesion? We found it 73% of the time by Rebus. Now, I want to point out how fascinating this is. All trials always talk about how they find the lesion with Rebus and it's like 90-something%. And then the yield plummets, right? We've all seen that across all platforms. Well, here our Rebus confirmation was that great, but our immediate diagnostic yield on Rose was one of the highest we've seen. And then when you followed up the definitive benign lesions, but they weren't granulomas, 91%. Highest yield documented for bronchoscopy so far, minus cone beam studies. And so, lo and behold, that's the yield you see with CT-guided biopsies. Though that wonderful paper that just came out that talks about the, 24% pneumothorax rate. So let's go through this real quick. 45 biopsies, right up front, immediate diagnostic yield. 32 patients walking out with a cancer diagnosis, 6 specifically walking out with granulomas. Then on immediate follow-up using a definition similar to the benefit trial, 2 non-specific benign inflammations that were followed up on. And then as you continue to follow these patients and ultimately went for the final diagnostic yield, we hit 91%. What's the real story here? The real story is that external imaging is the only way you're going to validate where you are. Because CT to body divergence is real. You can try to software your way through it across any of the platforms and you're going to continue to fail. And if you look back at one of Mike's original papers on cone beam, which is obviously an imaging-based navigation platform, using a nothing catheter, it was essentially an empty catheter for all intents and purposes. Mike's yield was in the high 80s, I think, right? But point was better than any of us had been doing with any kind of advanced navigation because he was using imaging, correct? It's all about imaging. And so this is all about imaging. Now, just real quick, there's another platform about to come out at some point if it gets FDA approved maybe, that we're going to be using that is building in tomosynthesis directly into a robotic-based platform. And with that, I'm going to shut up and say thank you. Here's my email, there's my cell phone. If you find yourself in the greater Chicago area, please swing on by our little hospital right over here. We're also a trauma center in case you get shot on the way there.